Welcome to Granger, everyone. Happy you guys can be here. Like Emily brought up earlier, we've been to React to Chicago meetups before. We talked about doing this. Today's the day we're doing this. That's really awesome. It's really special to me. I've been at Granger for over 6 years. We do a lot of cool things here, bounce around different teams. Emily summarized the gist of that, so I'll carry on. I have been really passionate about performance. Last year, I got the opportunity to spend a substantial amount of performance for web app front end, and we use React applications with Next.js here. Performance is a huge field. We spent a lot of months diving multiple streams of work going in a parallel, and so it was tough to choose something just specific to talk about, but I wanted to talk about something React specific. And so I was going to talk a little bit about a wow moment I had and walk you through, and hopefully you guys learn something new. So when it comes to, oh, wrong button. So when it comes to performance, wait. Is it working? Oh, it's slow. I was about to bounce. You see, that took too long. I got frustrated. I was about to hit the back button. But no, you see, when we expect things to work, like the last slide to this slide, we want things to work fast. We have expectations for what they should do. When those expectations aren't met, our customers are frustrated. We're an e-commerce store. And so we as engineers need to do and deliver them an application that works fast, responsive, to save them time so that they're happy customers and keep coming back. So what does that actually look like? Industry standard for web pages is supposed to be 3 seconds. That's like first contextual paint. If you use Lightning House, that's how fast customers are like willing to wait for a page before they think something goes wrong. Here are just some rough numbers on what the probability of bouncing is, which is going to a site and then leaving it as the page gets longer. So what that means is that last slide took about 3.5 seconds. So about a third of you should be getting up and bouncing right now. But no, in all seriousness, please stay around and hang out with us for a little bit here at Granger. As we add more and more complexity to these applications, they naturally get slower, so we need to be intentional about making them faster. And no one loves to go faster than my friend, Ricky Bobby. Web apps are meant to be fast. Internet technology has solved a lot to make them fast. So why aren't they fast? A recent study by Google showed that on average, web applications take around 3.5 seconds. Based off the stats that I showed earlier, we're trying to get that under 3 to decrease that bounce rate and give people that responsiveness that what they want. What does that mean? It means there's a lot of work to do out there on the web. That's good for us. In today's world, we're adding more and more code, and that naturally just builds up pages and makes them go slower. We need to be intentional about making them performant. That doesn't come free, that comes at a cost. Trade-offs and decisions that we need to make. And so when I personally am moving too slow, what my good friend always yells at me is, unhitch the trailer. He thinks I'm carrying a bunch of weight and that's why I'm moving slow. No, it's just, I'm moving as fast as I can, right? But web applications tend to carry a lot of weight, and we need to release that, delay that weight so that we could get the page as quick as we can to the users, because that might be the only information they need. Especially in a world of AI where we're delivering features faster than ever, those features are adding to our bundle. So we need ways to intentionally check what that bundle size is, segment it off, and give our users the experience they expect or deserve. So today we're going to be talking about lazy loading and deferring some of that trailer for later on. We're going to go through a hands-on example in just a minute. So what is lazy loading? It's a design pattern where the application should roughly stay the same, but we're changing how it loads and optimizing to the user's experience and behavior so that they get what they need when they need it and nothing extra. That's the easiest way for us to give them the performance that is right there with the application right there. If we were to not lazy load, it'd be like traveling for a weekend and bringing your whole closet. You probably don't need all those clothes. Let's just pack what we need for the weekend, and then that'll make us lighter, quicker, less decisions, and we can move on from there. So let's talk about when to lazy load. A few like high-level metrics that I like to look at and that kind of give me code smells are when page load time is over 2 seconds. So what that means is the actual document or the first thing that the user gets, if that takes over 2 seconds, that's too slow. We start investigating into that with Lighthouse tooling or the equivalent bundle analyzers to see what's taking us so long. Anything under than that, you're pretty fast. That also aligns with Lighthouse metrics are Google standards for like first contextual paint. Heavy components, anything below the fold. What does that mean? Like in the browser, anything that's not visible to the user, let's just not load it. That'll help just get them what they need as quick as we can. We can load that later on pretty easily. JS bundles over 50 kilobytes. 50 kilobytes is a lot of memory to handle the functionality that you need. If it's over that, let's think about breaking off and segmenting that functionality so that it could be delayed later on, or again, just giving them what they need. And components and images that are rarely used, those can also be delayed for later. So no one likes it faster than Ricky Bobby, but let's take a look at Ricky Bobby's web app because he's complaining that it's not fast enough. So let's see if we can make a quick few changes to make it faster and what that looks like. Here we got Ricky Bobby's order history page and includes a bunch of racing equipment. But what we see is that it's very slow. We take a look that he's complaining and the internet's not connected. That's crazy. There's no way. One second, let me see what's going on here. Yeah. Oh, sorry, I know. Gotcha, good, keeping me on my toes, keeping me honest. I apologize for the delay. We will make it up with some lazy loading though. Internet's back, that should work. Let's close that, perfect, okay. Clear this out, cool. I'm gonna share the screen, come over here. So back to Ricky Bobby's web application. We got his order history here. This is a simple application. I'm going to go into what the code actually looks like. We're iterating over through his orders, and we have a feedback form at the bottom. Pretty simple, except Ricky Bobby's a fast man. He orders quickly. He's got a lot of things going on. So if I reload the page, what I see is that this page, the document, which is the first thing that comes to the browser, over 50 kilobytes, and this JavaScript file is over 500 kilobytes. Let's take a look if we could defer some of that to later and make this page a little bit faster. What that looks like is first we're going to lazy load the cards themselves. That comes with the interface intersection observer, and we're going to only load what we need. We have a config variable here. We're going to load just 4 cards. Why 4? Because that's what the user's likely to see on both the desktop and a mobile application. Anything more than that, they're likely not seeing. So it's like virtualized below, and we don't actually need to return that data back to the client. So we're going to load 4 pages and save the rest for later. Here we're checking on if the scroll sentinel is reached. Once it is, we add more and more cards. So this is infinite scrolling going down is what we're looking at here. This is what it looks like under the hood. As we scroll down, we listen for this DOM element, and then we add more and more. So we'll show that in real time when we go to the next page. Here we see is that change alone dropped our document size. So again, the first thing that reaches the client and what is the bottleneck in this process, the JavaScript comes and renders after. We dropped it from 50 to 7 kilobytes. What's the trade-off we made there is we added some JavaScript. So we see that the JavaScript style goes from 590 to 615. This is just a demo application, so just these rough numbers and the rough direction that they're heading to is like what matters. What's more interesting is that then if we look at the document now, what we see is only 4 articles or like 4 cards that we're actually passing in, not all 20. That's where that speed and lack of size comes in. As we scroll down, we see the live addition of article cards that we're lazy loading into the page, and so on and so forth. But there's another question, which is how can we make it even faster? And so we've minimized the DOM substantially, but this JavaScript file seems quite large, over 600 kilobytes. So what can we do about that? We could defer it to later. Why? This JavaScript file contains a form element at the bottom that the user clearly can't see on the screen. It comes all the way down here where the feedback card, where we just ask for feedback. We don't need to load any of that until it's likely that the user is going to interact with it. So we'll save that for later on until they scroll to the bottom. What that looks like on this other side is, and this is where the wow moment starts, is React makes it so unbelievably easy, and this needs to be done intentionally. We need to intentionally bundle split here and tell it that, hey, this form is now going to have a different experience for a user, and we're okay with that. What that's going to do is bundle that separately, And we're going to save that load until it's actually needed in the DOM. What that looks like could be executed in different ways. Here we have just a simple logical condition that brings that element into the DOM, and that allows this to be rendered and the form to be brought into the front end. What that looks like on our fastest version of the application is when we go over to that, we see that, again, the document size dropped even more because we let go of that form. But the big change, the wow moment, is 600 kilobytes down to 400. All that kilobyte was added for demonstration purposes, but in part of the form. That could be things like analytics, clicking, form handling. I added a markdown library there so the user can be really mad when they leave their feedback and use like all italics, something like that. But we delayed that. We don't need any of that functionality because it's virtualized below here. When we see here, we still have the 4 articles. And then as we scroll down, I'm gonna go through this piecemeal. We wait for all these to be added here. And then we have our very large form here at the bottom. The user can still interact, type in this, work in as needed, but they didn't even notice that it was missing. So for all those users that came to the top of the application, it was nice and quick. The most impressive part is that tree shaking happens with bundling and removes anything that you don't need, but we're now intentionally changing how the bundle behaves. And we see that for the first time, we created our own chunk of JavaScript here, which is 587. So that's where that size of JavaScript file magically disappeared from page load and is deferred on to later on. Now this has a vastly different experience for our users. They're able to hit our page quickly, interact with what they need, and this heavy form is only brought up if they need it. They don't even notice a difference. If they scroll down to the bottom, it's the same experience as before, but for most users, they'll stick to the top and get the information that they need. So we talked a little bit of the trade-offs is we're adding JavaScript for a little bit less DOM markdown. So that document object's the first thing to go. So we want to make that as light and lean as possible. That adds a little bit of complexity in our JavaScript decision-making, can add changes to our UI that need to be discussed, potential layout shifts, but those can all be adjusted for and should be designed for. I'm having this conversation today to have performance at the front of your mind as we start building apps from small to large, and as you talk to other teams, back-end teams, front-end teams, we want to talk about performance early on. Techniques like this help us chunk size our data, talk about putting elements in the right spot so that they can be deferred. Those decisions early on across our whole application can have large and vast changes for us. And this helps us strive for that 3-second rule or that industry standard on where pages go. So with a little bit less DOM and a little bit more JavaScript, we get this beautiful blend of what I like to call the shake and bake. It helps you go nice and fast. And you got the Ricky Bobby of the Carl Jr. helping Ricky Bobby get across the finish line. Carl Jr. is there to help. And just like that, we got our slingshot method to win the day. But this time it's with HTML, JavaScript to get that page nice and fast to the users. Thank you very much. Okay.
Back for a redesign.
Mm-hmm.
Analytics thing was too much. How's that?
Yeah, that's a good question because in the reality, this sounded really easy, too good to be true. And so, sorry, this demo in the fictional world sounded, and in the real world, everyone thinks they're super high priority, thinks everything needs to be preloaded super fast, that the user is going to care about everything. The way I make a lot of decisions towards that is with our observability tools and looking at what our users are actually using. So just a data-driven approach on showing what actually gets touched. Otherwise, everyone's very passionate about the feature that they're building, what they're responsible for, their team, their product. And sometimes we need to make that negotiation, and data helps point us in the right direction there. Good. Yeah. Yeah. I chose lazy loading because I like watching the DOM interact interactively as we load down. I know that's like part of like the wow factor, And I enjoy that, and it makes a lot of sense conceptually. Pagination is a little bit different because it is like a different page or component that you might render in. Infinite scrolling is when the order of the content matters less, and we want to just continuously show that to our users. Pagination is where the order matters, and we want to go to specific points. So on a technical note for your question, order history pages tend to be paginated because we're going to specific orders at specific times where the order matters, right? So what we don't want to do is just show someone wants to go in an order a long time ago. We don't want them to be in the middle of their infinite scroll. And like, who knows how high or who knows how low they are. Then we're retrieving data, trunk size at a random spot, and that experience is wild. They want to go to the top. They now have to scroll to the top just because they clicked on an order. Pagination makes more sense in that scenario.
They took one of
Mhm.
the card to explain it. While going back, how do you maintain for ads? Because the long flows
Mhm.
back to the initial the page, like how do you?
Yeah, it's a good question. So there's just like some extractions that are done there. So what you would do is you could hook into like the back click handler and intentionally add functionality. And you would also probably need a pass state too through memory. But essentially what you're doing is if a user's on an order detail, that has a unique identifier of some kind. And when they go back, you know what page they were on because it's in the history, but then you could also know the place in the DOM or where they are scrolling wise because of that unique identifier. So then you would add logic to scroll to that. Because I don't think that happens automatically, especially if the page is like dynamically rendered. When you go back, it might be a different size than when all the content is loaded. But yeah, that requires a little bit like of intentional programming there. I had one more here.
Yeah, like content that we use any like server-side rendering to give sort of the appearance of that completed load page while you're waiting between the backgrounds to make it from a smooth experience.
Yeah, so a lot of techniques are needed. And the big thing that I'm trying to preach is just to have this in the forefront of our mind as we design things. I feel like oftentimes we try to implement features and then performance later on. That's a harder sell to business, and B, sometimes we just like pin ourselves in a rabbit hole and other priorities come up and we need a context switch. When it comes to server-side rendering, we use Next.js on a lot of our applications, and a lot of that comes out of the box. We do different examples of it, but especially with like the newer versions of React server-side components, it's helped a lot. A lot of also the component files I was showing you have use client at the top, but they're still rendered on the server and passed up. So that's why I was able to show the difference between ones that had feedback form and aren't, and ones that had a lot of articles and didn't. All that's coming directly from the server. So the user's just hitting the URL and the server returns that page. I was trying to show that exact page that comes up. I could have done that in the networking tab to prove that exact what is that resource coming, but it is like one-to-one because I didn't do any interactions on the browser. One last one, we'll take this one too.
Yeah, quick question. So like this is a demo app, obviously, but in the production app, let's say I'm looking for a particular set of pliers. If we're virtualizing the DOM, I jump in the page and I try to create that for that particular version of the pliers. That obviously would be in the DOM. How do you handle that trade-off in a real life setting?
Yeah, I think I'll also share an example where I think that problem has come like for us at work. So I'd say Command F is a byproduct, and that's where you want to encode functionality and drive the user towards the behavior that they want. So things like searching through a page is something a user wants to do on order history. So we have a search bar for that. And then that actually queries the database directly to get them all relevant. Because we that'll be like fuzzy searching off the words that they're searching and showing them multiple results. So that would never be able to be handled on the client side due to the vast volume there. I will share off that. An example I think that's interesting is when the user tries to print the page or do something like that, more an unconventional user action, the DOM elements aren't there. And so that's actually where like the trade-off is, like if you want to print it right away, then that information isn't there, and you have to trigger those lazy loads automatically if you have chosen this. And that is one of the trade-offs that needs to be considered. A lot of that is like how much your customers like to print. Side note, Granger customers like to print. We spend a lot of time talking and thinking about that on every team I've been on. Here.
Like, B or something like that, of those lines, or?
Yeah, so we could hook into click handlers and drive the behavior we want. So we kind of do that regardless. Like we have media queries to show them more or less data. We massage what they may or may not see after they hit the print, but you could do a lot more like that and hold that interaction until something's loaded. Thank you very much. Really appreciate the questions.